All right, let's take a look at finding the different areas of um, the distances between the mean and the standard deviations on a normal curve. So first off, the area underneath the entire curve, and this is a special property of this curve specifically, is 1. So that's 100% of the people are represented in this normal distribution. So the area, the total area is 1. Now we also have the 68, and the 68% goes out to the 1 standard deviation left and right, and then the 95 and the 99.7 rule. So from the 68 rule, the way this is labeled, A1 on the left, A1 on the right, I know these are equal areas because of the symmetry of the normal distribution. So we actually have 2A1, and that equals the 68%. So if we divide both sides by 2, we can get A1 is 34%. So this is 34%, this is 34%, and we can see easily adding those up, we get the 68%. Okay, next up, we have this area, that's 95%. Again, this is from the empirical rule, 68, 95, 99.7 rule. Now the 95% covers all of the area between the first 2 standard deviations left and right of the mean. So we have A2, an A1, an A1, and an A2. So we have 2A1 plus 2A2, and that is 95%. Now here's where we start to recognize some patterns. 2A1 is 68%. There's 2A1. So I can just replace that with 68%. We already know this area. So we have 2A1, that's 68 plus 2A2 equals 95%. Okay, so now we need to start solving for A2. 95 minus 68 is 27. So if we subtract the 68% from both sides, we have 2A2 equals 27%. We divide by 2, and we get 13.5. So A2 is 13.5%. And now none of this you have to do in your head. Divide by 2. There it is. So this is 13.5% and 13.5%. The last one, well, the second to last one actually, is the 99.7% rule. So if we look at the area between the 3 standard deviations to the left and 3 standard deviations to the right, it covers A3, A2, A1, another A1, another A2, and another A3. So we have 2A1 plus 2A2 plus 2A3, and that all equals 99.7%. Now, notice 2A1 plus 2A2 is 95. So all of that is 95. So we can do a similar substitution. And then we need to subtract. I can do that one in my head, but we'll verify all this in a second. 99.7 minus 95 is 4.7%. And then dividing by 2, we get A3 is 2.35%. So this is 2.35%. This is 2.35%. And let's double check that. So we have 99.7 minus 95 divided by 2, 2.35%. Finally, we have the entire subtracting 100%. So the 100% is basically all of the area underneath. And we're letting A4 not just be to the, so A4 is not between 3 and 4 standard deviations of the mean. A4 is the rest of what's underneath that tail. So A4 goes on forever to the left and to the right. So we have 2A1 plus 2A2 plus 2A3 plus 2A4 equals 100%. And once again, we have a previous result. 2A1 plus 2A2 plus 2A3 is 99.7. So we can replace all of that with 99.7. And you'll start to see the pattern a lot easier as you do this 1 or 2 more times on your own. Subtracting the 99.7, we get 2A4 equals 0.3%. Dividing by 2, we get A4 equals 0.15%. So the tail end, 0.15%. 0.15%. Okay, excellent. This is how you can take the regular rule, 68, 95, 99.7 rule, and break up the normal distribution to know the percentage of all of the different regions in between the standard deviations. This really helps out in the homework, so you'll want to practice this. Let me demonstrate one other approach quickly with the calculator. First off, 68%, divide by 2. There's your 34s. 95 minus 68, this is the 68, 95, divide by 2. There's your 13.5s. 68, 95, 99.7 minus the 925, the one before it, divide by 2. And finally, the 100 minus the 99.7 equals divide by 2. So you can generate those numbers very quickly with just the subtracting the consecutive numbers in the 68, 95, 99.7 rule, and then dividing by 2. You can generate those quickly on demand as you need them. All right, I hope this helps.